Learners, welcome to MMI online classes. Today we are going to do Euclidean geometry and we are doing proportionality. So we're going to first start with theorem 1. Theorem 1, it is, let's first start how to prove the theorem. Let's say we are given a triangle like this. Okay, it's going to be A, E, D, and C here. Okay, so what you're gonna first do is you're gonna first construct your triangle. So take note of how I am constructing and take note of colors I'm using when constructing. Firstly, I'm gonna construct a height from this point D, like that, and then this height we're gonna call it height K. Okay, so and then after that, okay, then I'm gonna use another color. Let's use purple. Use another color to construct the second height. Okay, the second height is gonna be from E going that way. This is 90 degrees. This is 90 degrees. Sorry, this is 90. My God, sorry. This is 90 degrees. Oh, okay, it doesn't want to. But anyways, let's continue. And then after that, after you've constructed, you're gonna construct again your bottom part of the triangle, which is DEBC. You're gonna construct like that. You're gonna use the same color. So now take a look of how I am structuring the colors from this height, which is blue. My God, that line. From this height that is blue, I'm gonna draw another line like that. Okay, sorry, my line isn't straight. Let me erase that. Oh my God. Okay, so it's gonna be something like that. Okay, so you're gonna construct another line going that way. Okay, and then we're gonna construct another line going that way. You see, so now we've created two internal triangles, the purple triangle and the blue triangle. So the purple triangle has a height of h. Okay, and then what we're gonna do here, we're gonna work with areas. So firstly, we're gonna say the area of triangle, the area of, let me use small font. So the area of triangle ADE. Okay, ADE. Okay, so the area of triangle ADE divided by the area of triangle BDE. Okay, B, D, and E. Okay, so after that, the area of the top triangle divided by the area of the bottom triangle in correspondence to the height. Okay, if the height is purple, they use the purple triangle. If the height is blue, use the blue triangle. Okay, so after that, you're gonna say this is going to be equals to, okay, you know the height by now. For sure, you know how to calculate the area of triangles. So it's gonna be 1/2 for the top one. It's gonna be 1/2 our height, which is the purple height. Okay, because we've used the purple triangle. okay, as our bottom triangle in this writing. So what we're gonna do is it's going to be 1/2 times the height, which is h, it's the purple one, times AD, which is our base. Remember, the base, the it's the line which is perpendicular to the height. Okay, that's your base. So you're gonna say 1/2 still the same height. See, triangle BDE has the same height as triangle ADE in relation to this big triangle, this purple triangle. You see this purple triangle, this one, this purple triangle, it has the same height. Okay, so we're gonna write our height there, times BD. In this case now, our base is BD. Okay, BD. Okay, so as you can see here, you do your math. This is going to cancel, this is going to cancel. We are left with AD divided by BD. Okay, and now we move to the second part of our writing. Let's go to the blue triangle. Okay, so we're gonna say area of the top triangle again, ADE. Okay, triangle ADE, excuse my handwriting, divided by area of triangle CED. Okay, so what we're gonna do here is we are going to consider the blue triangle now in relation to how we've constructed. Okay, so triangle ADE, we're gonna say the area, it's gonna be 1/2. The area is going to be 1/2. The height, now our height is no longer h, but it's k, because we are using the blue triangle. K times times AE. Okay, AE, because AE is now our base. AE, because the base is perpendicular to the height. Then divided by 1/2. It has the same height, considering the blue triangle. As you can see, it has a height of k times EC in this case, because EC is our base on this triangle. Okay, and then what we're gonna do is, if you don't see the triangle, let me try to take it out so that you can see how I did that, how I considered this triangle. I'm taking it out. Okay, so this is the height k. Okay, this is my 90 degrees. Oh my god, this is my 90 degrees. Okay, this is the triangle, this is my height k. So what I did here, this is let's say this is that line, this is E, this is E, and this is C. So what I did here is that this is a right angle triangle. A right angle triangle, the height is going to be that height that is opposite. The height is going to be this one, because it's a right angle triangle. As you can see, there's 90 degrees here. Okay, so we're gonna say that height 1/2 k is our height, and the base is where the height is perpendicular to. we can take this whole line. However, because we have labeled that this whole line can be EC, as you can see that it also goes in hand with EC, meaning we can just take EC as our base. So that's how we do it. Okay, as we continue. So now we are closer to proving that this is equal. So we're gonna conclude here that this will cancel that. It's gonna be AE divided by EC. Okay, now, but remember that but we should remember that okay, oh my god, okay, now it is clear that now it's clear that the area, let me use the pink. Okay, let me erase that. Now the area of triangle ADE, okay, is equal, not ADE, oh my god, the area of triangle BDE. Okay, looking at our diagram, triangle BDE, okay, it's equal to the area of triangle CED. Okay, why? Here's our reasoning. So we're gonna say is equals to area of triangle CED. Okay, so this is the reason. It's because your reasoning, you can either write it on a table depending what your teacher says, or you can just put them in brackets. So mine, I'm gonna put them in brackets. My reasoning is that it has the same base and they have the same height, okay, and lying between parallel lines, okay. So that's my reasoning, that triangle BDE is equal to triangle CDE, and they lie between parallel lines. Okay, so the parallel lines, it's DE and BC. Let me just highlight them. These are the parallel lines. Okay, those two lines are parallel, and then if they are parallel, meaning they're going to have the same base, same height, and meaning the area is going to be the same, because if you multiply the same base, the same height for each area, they are going to give you the same value, meaning the area is the same. So we continue. Now we've proven that those two triangles are equal. Therefore, we can now conclude and say, therefore, the area triangle AADE, okay, divided by area of triangle BDE is equal to the area of triangle ADE divided by the area of triangle CED. D. Okay, so if these two are equal, therefore we can now conclude and to say that AD all over BD. Remember, we have calculated our areas on our previous writing, so we can now conclude that these areas are now equal. Therefore, these lines are also equal. You see, so that is how you prove. Sorry about that. That is how you prove your proportionality for theorem 1. So you should do more examples. On my next session, I will do examples on how the questions are going to come about and how you are supposed to attack them. But now this is for proofing.